Assalamualaikum and hi. In this video, I'm going to show you one of the applications of Laplace transform. Um, in this course, we just apply the Laplace transform in order to solve for IVP. IVP is initial value problem. Okay, initial value problem is a differential equation that comes with initial conditions. Okay, when you have first order, so that you have one initial condition. If you have second order, you will be given two initial conditions. Okay, so how the method works? Okay, the method of solution. First, you must be given a differential equation. Okay, before that, you must be given a differential equation. For example, y of t at y prime. This y prime is as a function of t, time domain. Okay, if you have this one can be written as dy dt. Okay, or you can be given the y double prime, so second order. So y double prime is also a function of time. So this one is d square y dt square. Okay, so at first you are given a differential equation in time domain, so that you need to transform the dE. When you transform the dE, you will have a function, equivalent function in frequency domain. Okay, so when you transform yt, so you will get ys. Okay, so that is the idea. The second step is you need to substitute the initial conditions on the transform function. Then you need to solve for ys. You try to factorize your ys. Other than ys, you need to bring it to your right hand side of the equation. On your left, you just have ys. Okay, then you need to apply the inverse of Laplace transform. Okay, so that is your solution. Okay, so without any delay, so let us try to solve for one example. But where is our table? So it's okay lah. Okay, so let's consider that we want to solve for the first order first. This one. So we have y prime minus y equals to 1. So first step just now is we need to transform this function. So take the Laplace of y prime, okay, minus Laplace of y equals to, take the Laplace transform both sides of the equation simultaneously. Okay, so that is the first step. As you can see on your table of Laplace transform, okay, where is the table? Lah, hai table ni pun. Okay, now your y prime is this one. Y prime, when you transform, you have sys minus y0. So go back to our calculation. Okay, so y prime is sys minus y0. So done with y prime. So minus Laplace y. Laplace y is Laplace y of t. When you transform, you will have Laplace y. You will have y of s equals to, your right hand side is 1, so 1 over s. Take the Laplace transform both sides of the equation simultaneously. The second step is you need to substitute initial condition. You have y0 equals to 1. So this one is y0. So this one equals to 1. So just to simplify the function, so we have sys minus 1 minus ys equals to 1 over s. Okay. So the next step is we just want to remain on the ys on the left. Okay, the other things you need to bring it to your right hand side. So what I need to do here is I try to factorize my ys first. So I have s and this one minus 1. Okay, minus 1 equals to 1 over s. And do not forget here you have minus s. Minus 1. We try to bring it to your right hand side, it becomes plus 1. So let's say this one plus 1. Okay, so you have 1 plus 1 over s. But as I told you, we don't want anything on your left except for ys. So that ys equals to, okay, your left hand side only ys. So ys equals to 1 over s minus 1 plus 1 over s minus 1. Right, so this is our function. Okay, look. This is our ys. Our question just now is y prime of t So the solution that we want to get at the end of the solution is y as a function of t, not ys. Must be yt. So how to get yt? You have ys. In order to get yt, what you need to do? Yes, we need to take the Laplace inverse of your ys so that you have yt. Okay, so now I want to take the Laplace inverse of 1 over s minus 1, okay, plus 1 over s minus 1. You can solve this one separately by using linearity. Laplace inverse of this one and Laplace inverse of this one. Okay, but you need to do twice, okay, because this one you can simply refer the table, but this one you need to apply, you cannot refer the table. But what you need to do is you need to apply the property. Okay, first when you try to solve for DE or IVP, until you get ys, you want to take the Laplace inverse of ys, what you need to do is ask yourself, oh, can I just refer the table to get the solution? This one, yes, but not this one. If you cannot simply refer the table, what you need to do? Yes, you need to ask yourself, I need to apply the property, but what type of property? Is it linear? Is it first shift, or is it partial fraction? Okay, so for the second one, it is obviously you need to apply the partial fraction because you have perfect factorization here. Okay, since you have to do twice your work, double your work, so why not we just simply use or apply only one method, which is partial fraction. In order to apply the partial fraction to solve for this one, both, okay, both simultaneously, so I try to make the denominator same. Okay, so what I need to do is I need to multiply this one by s. Okay, so I have s plus 1 over s minus 1. Right, so that is the function that I need to take the Laplace inverse. Okay, so I just apply one partial fraction here. I try to separate the solve it separately. Okay, s plus 1, so that I have a over s plus b over s plus 1. Okay, cross multiply, I have s plus 1 equals to as plus a plus bs. Okay, so for the s term, I have a plus b equals to 1. And this one is just a constant, a equals to 1. When a equals to 1, okay, a equals to 1, therefore b equals to 0. Okay, so I just have a over s. Okay, so a over s, take the Laplace inverse of this one is equivalent to take the Laplace inverse of a over s and b over s plus 1. Since b equals to 0, what weird, b equals to 0, so that I just take the Laplace inverse of a over s. So I have Laplace inverse of 1 over s plus this one is 0. So Laplace inverse of 1 over s is 1. Okay? Am I right?